Hello friends, welcome to the third lecture of assignment problem. Today we will discuss about maximization assignment problem. So here 5 persons and 5 counters are given. So we have to allot each counter to the person so that the profit will be maximum. And Hungarian method is to solve the minimization problem. So first step is to convert this assignment problem to minimization problem. So here the highest value is 62. So subtract each value from 62. Each value of this matrix from this 62 we have to subtract. So 62 minus 30, 62 minus 37 and so on. All values are subtracted from 62. And now this is converted to the minimization assignment problem. Now next step we have to solve it by Hungarian method. So first step is subtract smallest entry in each row from all the entries of that row. So in the first row 22 is the minimum value. So 22 will be subtracted from all values of that row. Similarly in the second, third, fourth and fifth row the minimum of each row is subtracted. So after this you will get this is row reduced matrix. Now we have to subtract smallest entry of each column. So in the first, second, third and fifth column 0 is the minimum value. So these column will remain same. So only in the fourth column 4 is subtracted from all the entries of the fourth column. So here 12 minus 4 8, 19 minus 4 15 and so on 4 is subtracted. So after column and row reduction you will get this matrix. So now we have to assign in this matrix. So when you want to assign, again you have to scan row wise. So if single 0 contains in the row, encircle that 0 and strike out the column in which that encircle 0 contains. If more than one zeros are there, then skip that row. And after row and column scanning, we have to assign that zeros. If there is no single zero in any row or column, then assign in any zero arbitrarily. Now in this case, we can see here two zeros are there. Again in the second column, only single zero is there. So we will assign that 0. And that 0 is in the first column. So strike out first column. Now move to the third row. In the third row, there is no 0 now. This 0 is already striked out. So move to the next row. In the fourth row, two zeros are there. So we will skip this one. In the fifth row, single 0 is there. So assign that 0. And that 0 is in the second column. So strike out second column. Now row wise scanning is completed. Now we will go for column wise scanning. First and second column already done. In the third column, two zeros are there. So skip it. Now fourth column, single 0. So assign that 0. And that 0 is in the fourth row. So strike out fourth row. Move to the next column. In the next column, this single 0 is there now. Assign that 0 and that 0 is in the first row and strike out that first row. Now just see all zeros are either covered or encircled. Here it is there. So count how many zeros are there. 1, 2, 3 and 4. 4 zeros are there and the order of matrix is 5, which is not equal. So order of matrix is not equal to number of encircle zeros, then optimal condition does not reach. So we have to move to the next step. Next step is select the smallest element of all uncovered elements. So here uncovered elements you can see here in the blue area or blue cell. The smallest entry is 4. So we have to subtract this 4 from all these uncovered elements. So 13 minus 4, 15 minus 4, 4 minus 4 and so on. So you will get this one. So subtract 4 from all uncovered element. and add that 4 to the intersection point of two lines. So intersection point you can see here, this line and this line. So here 10 is the intersection point, 3 is the value where the two lines are intersecting. Similarly 15 and 2. So we have to subtract this 4 from, we have to add this 4 to wherever the lines are intersecting. So 10 plus 4, it will be 14. Then 3 plus 4 will be 7. 15 plus 4 will be 19. And 2 plus 4 will be equal to 6. And other elements keep as it is. This gray color cells are there that are other elements. So what are the steps? Uncovered element we have to subtract from all uncovered elements and add to the intersection point, and other element keep as it is. So we will get this matrix. Now this is again like a first step we have to third step we have to apply. We have to scan row wise for assigning the zeros. So to scan, observe first row, two zeros are there, so skip it. Second row, two zeros are there, skip it. In the third row, this single zero is there, so assign it. And that zero is in the first column, so strike out first column. Then next row, two zeros, skip that one. Fifth row, single zero is there, so assign it. And that is in the second column, so strike out second column. Now row wise scanning is completed. We will go for column wise scanning. First and second column already striked out. So move for the third one. In the third one, two zeros are there. So that we will skip. In the fourth one, this zero is there. So encircle that zero. It is in the fourth row. Strike out fourth row. Move to the next column. In this fifth column, two zeros are there. So we'll skip it. Now column wise scanning completed. Again we'll go for row wise. So in the first row, two zeros are there. So we will skip it. In the second row, only this single zero is there. So encircle that zero. And that is in the fifth column. So we will strike out fifth column. Right. Now third row already there is no zero now. In the fourth row it is striked out. Fifth one, there is no other zero. Row wise scanning completed. Now go for column wise. First and second already striked out. In the third column, this single zero is left now. So encircle that, and it is in the first row. So strike out first row. So now all zeros are either encircled or striked out. So how many zeros are there? 1, 2, 3, 4, 5. So 5 zeros are encircled and it is equal to the order of matrix. So optimal condition is reached. So now we will get the maximum cost. Here maximum profit problem is of maximization. So we will consider whatever matrix is given in the beginning. So we will assign values in that matrix. So the maximum cost will be equal to 40 plus 36 plus 40 plus 36 plus 62, which is equal to 214. And the assignments will be, first counter will be given to person C, second will be given to person E, third will be given to person A, fourth will be given to person D, and fifth counter will be given to person B. And this is the optimal solution. Thank you so much for watching.